Hi everyone, I'm going to show you in this video how to use your Texas Instruments graphic calculator to draw functions, also to calculate values of functions, both x and y, or whatever they happen to be called in the context of the problem you're working on, and also find local max and min. So to show you how to graph functions using technology, I'm going to use this problem from the Hazy Maths Methods textbook. In this problem, we have a quantity E, which happens to be the effect of a pain-killing injection, and it's modeled using this surge function. So the first thing that we are asked to do is draw a sketch of the graph of E against T. So we can do that by inputting our function into the graphics calculator. I'll just go back one step. So when you turn your calculator on, you'll be here. So to input a function and graph it, we click y equals, and we simply enter the function. So y is going to represent E, so 750. We find our variable t, or it'll plot it as x, but so 750x. Now we're looking for E, so we'll find that the exponential function above its inverse function, the natural log. So second E. We use this for a minus in functions, 1.5 t. Okay, so that is our surge function, and we click here to graph it. Now this never works, so I'm not sure what it's going to come up with, but it probably won't be any good. See, I was right. Okay, so the problem is the Texas is not very smart when it comes to graphing. It doesn't know what range of x and y values to use unless you tell it. So you do that by clicking on Window, and you need to manually set the range of x values at least. So we know that time is greater than 0, so x min can be 0. So this is our horizontal axis we're doing at the moment, and we know, well, we actually don't know what the maximum value of time we're interested in is, but we can see in the context of this question that we at least need to know the effect of the drug at 2 hours, so x has to go at least to 2 hours. So I'm going to go out on a limb and suggest or say that, you know, most operations are probably less than 5 hours, so I'll use x max equals 5. In terms of the y values, well, I know that they're saying here that we need 100 units. E has to equal 100, so I might just use my minimum value of y as 0 and a maximum value of 100. And try and graph that. Okay, so there you can see that we have part of a surge function, which is chopped off the top. So I have to reset the view window to get the top in. So I'll just move the maximum value down to 200 units and see how that looks. Much better. So to sketch the graph, I'll just quickly show you what that should probably look like. So, okay, so you can see here that I have sketched a very rough surge function to match what my calculator produced. So the main things to remember are that you need to show, need to label your vertical and horizontal axes. So, which I've done. So this is the drug effect, E, in units, and this is the time in hours. This was the shape of the function. There is a maximum there that we'll find where that occurs in a moment. So, okay, so the next thing that we are asked to do in the question was to see what is the effect of the drug after 30 minutes and 2 hours. So we can use technology for this as well. Now, the way we do that is we can explore different values of this function in a range of ways. We can click trace, and we can just sort of move a point on the function and see, that at certain values of time or x, we get certain values of the effect. But if we want to know the exact effect of the drug at 30 minutes, a better way is to use this calc function here. So we go second calc, and we're going to try and find a value. So we enter value, and okay, so if we need to find the effect of the drug at t equals 30 minutes, well, since t is measured in hours, 30 minutes is 0.5 or half of an hour, right? So we just go enter, and we can see that at t equals 0.5, E is 177 units. At t equals 2 hours, just do the same thing. Second calc, value, and we put in 2 hours. And so at 2 hours, the effect has decreased to 74.7 units. So that's quite a lot quicker than entering this all into your calculator and substituting t equals 0.5 or t equals 2 into this. So it's a much faster way to find values using the graphing function. So now the next question was to find when the drug is most effective. So we're trying to find the time that corresponds to this local maximum. Again, we can use the second calc function, and we can see that we can look for a maximum or a minimum. So we're interested in a maximum value here. Now the calculator is a little bit clunky here as well. It's asking us to define a left bound, so we have to just arrow the cursor left of our maximum and say yes, that's our left bound, and then arrow it right, that's our right bound, and then tell the calculator to have a guess. Enter, and we can see that it's found our maximum here. So the maximum occurs at 0.6666, which we know is 2/3, right? So at t equals 2/3 of an hour, we have a local maximum, and the value of the size of the drug effect at that time is 183.9. So it didn't ask us what the size of the effect was, but it asked us when it was most effective. So the answer there is at t equals 0.666 hours, or 2/3 of an hour. So the next thing, and I think this is the last thing I'm going to show you, is it's asking us to find a time when the effect is equal to 100 units. So again, we can use technology for this, and again, it's a little bit clunkier than it really needs to be. But so we don't have an option to find to enter a y value and find an x value. But what we can do, just let me quit out of this. What we can do is we can graph a horizontal line where y equals 100 units, and click graph. So what we're interested in here is the time that the effect rises above 100 units. So we're looking for the intersection point of the function and this horizontal line here. And we're also interested in this time here where the effect drops below 100 units. So the way we find those 2 points is by using second calc and looking for the intersect. Now we have to tell it which two curves we're interested in. So yeah, this can be our first curve, and this is our second curve, and we want it to guess, and it's found an intersection point for us. So the effect is just dropping below 100 units when the time is 1.695 hours. And we need to find another intersection point. So we can do it again, repeat it. So we'll just move the cursor a little. Alright, so we'll select that as our first curve, and this is our second curve. Get it to guess, and now it's found the first intersection point, which is at t equals 0.173 hours. So the operation can commence at 0.173 hours, and it needs to finish by 1.695 hours. Now, the last part of this question, which is to find when the inflection point of the graph occurs and what its significance is. Well, the significance is not got anything to do with graphing using technology. This inflection point tells us when the effect is decreasing at its maximum rate. So the way to find the inflection point, well, there's a number of ways to do it. We can differentiate the function twice and set it equal to 0. Another option would be to differentiate the function once, graph this, and then look for the local minimum in the same way that we just looked for this local maximum. So I think that's probably enough. You've got a bit of an idea now about how to use the calculator to graph functions, how to set the view window, how to find values, both x and y values, and find local max or min. And yeah, so good luck. And thanks for watching.